We know how to factor quadratic equations, but today we're going to extend that to more polynomials. I'm going to go through 4 techniques, and it's not going to take care of every polynomial, but as we get smarter, I'll teach you some more tricks. But these 4 today, the first one, always factor out a greatest common factor, and that just means look at these 3 terms. For example, it looks like I could factor an x out of each of those. So if I factor out an x, it's like dividing each term by x. So that's what it would look like after the greatest common factor is out, but I think I can probably factor this quadratic again, yeah? Multiply to make negative 15 and add to make 2x. Are we thinking a plus 5 and a minus 3? So there's our answer. We leave that x on the front. That is part of our answer. It shows that it's still a cubic function because I still have 1, 2, 3 x's left in there. So the moral of the story is you should always check to see if there's something you can factor out of both terms. In this case, a 3x squared, leaving me with a single x and a 5. And this time that can't be factored any further, the x plus 5. So that would be my answer. That is the factored form for that polynomial. The second method is grouping, which we practiced this when we did that AC method from quadratics. But if there are 4 terms, it's worth a shot. It's not going to work every time, but a lot of times they set it up so it will work. In these first 2 terms, I can factor out an x squared. In the second 2 terms, I can factor out a negative 9. And you can tell if it worked or not to see if do you have a matching piece in both of those? Yes. So that means that out of those 2 terms, this term and this term, I can factor out an x plus 7, leaving me with the x squared for the first term and the minus 9 in the second term. Before you circle your answer, just make sure that there's nothing else that can be factored, and I think I've seen that factored before. Have you? So what multiplies to make negative 9 and adds to make absolutely nothing? Did you notice there's no x term? And that would be a positive 3 and a negative 3. They called that the difference of squares. That was a type of factoring we knew for quadratics. So we actually have 3 factors in this one, and that came out to be a cubic function if we would distribute it all back together. The next method is a super special one. It's called special products, and the only time you'll use these is if you see 2 terms and they both happen to be perfect cubes. And there's these fancy formulas that go with them. Some people like to memorize them. Maybe you'll accidentally memorize them, but I will just give them to you. So you'll know that you're dealing with one of these if you see, like I said, 2 terms, but you notice something about those 2 terms. The first one is cubed, and the second one is also something cubed. Can you think of what cubed makes 27? 3 times 3 times 3? So this is the same thing as x cubed plus 3 cubed. And it says that if we have something cubed plus something cubed, then that would equal the something plus the something. Are you with me? The something squared minus the something times the something plus the something squared. So basically, whatever you see as your A and your B, whatever those 2 things that are cubed, that's going to be your value for A and B. So to factor x cubed plus 27, it is x plus 3, x squared minus, I'd rather write it 3x, plus, and then b squared would be 3 squared, which is 9. Just look at that for a minute. Did that make any sense? Again, the A and the B, in this case, were the x and the 3, the things that were cubed. We'll try another one with this other formula, very similar. P.S. You're never going to be able to factor the quadratic that's left over. Not in a nice way anyway. So once you've done that, you're finished. And if you have doubts, go ahead and redistribute all of that. Everything should cancel except for the x cubed and the 27. It's kind of cool. Let's try this other one, except those are hideous numbers. Oh, because I should always factor out a greatest common factor. What can I factor out of a 16 and a 686? I can get at least a 2 out of there. And then I could take from the x terms, the x squared. So 8x cubed minus 343. I'm not sure I could have factored out anything bigger than a 2. And actually I'm starting to see something. 8 is a perfect cube, isn't it? 2 cubed is 8. It actually might be worth writing out these just so you can start to recognize all of your perfect cubes. Would you like to do that? Oh, that's a tough one. Is that 216? No. Oh, it's 3. Ooh, 343, isn't it? Isn't it? So I think what I have here is that is the cube of 2x, and that is the cube of 7. So I think I could factor this using the subtraction sign, using the difference of 2 cubes formula. So once more, that 2x squared is still part of the answer, so I'm going to leave that there. But I'm going to be able to do this stuff by following the little formula up here. So a minus b in this case is 2x minus 7. A squared would be 2x squared, which I'm going to write as 4x squared, plus a times b, so 2x times 7, 14x, plus, it says b squared at the end, and my b was 7, so a little 49 right at the end. Well, that's gorgeous. The last method is just kind of using what we knew from quadratic. So I had a little remember difference of squares. X squared minus 81 was x plus 9, x minus 9, because the O and the I from FOIL cancel. And the reason I bring that up is because this sort of reminds me of 2 squares. You know, like that would be 4x squared, and oh gosh, what is this? Is that 25 squared? I think so. So this almost reminds me of sort of a form of a quadratic that I used to deal with. So I'm going to pretend I'm factoring a quadratic, and I'm going to think, okay, what times what will give me 16x to the 4th? And I'm going with a 4x squared and a 4x squared. And then what times what makes 625? 25 times 25 makes 625, right? And if I make one positive and one negative, I win. And like I said, you should always check to see if anything can be factored more. Yeah, it turns out that there is no sum of squares. So, for example, this first little guy over here where it says 4x squared plus 25, that one's not going to be able to be factored again. But this one is a difference of squares, so I should be able to factor that one more time. Here's how that's going to look. So leaving this one alone, And then this one, factoring it as a difference of squares. What times what to make 4x squared? 2x and 2x. What times what to make 25? 5 and 5. Make 1 positive and 1 negative. And that is our final answer. It'd be nice if we could break all of these terms down to linear, but in that case I had to leave that one quadratic. But your goal is to factor that all the way down if you can. Alright, last one. What should we always check first? To see if we can factor out something, and I think I can factor out a 4 from each term and an x squared from each term, leaving me with x to the 4th minus 5x squared plus 6. So that's after factoring out. Does this part right here remind you kind of a quadratic looking thing? Like if it wasn't a 4 and a 2, if it was a 2 and a 1, it would look sort of quadratic. Let me show you what I mean. The 4x squared is just going to hang there. But I feel like I could factor this sort of using that reverse FOIL kind of idea. What times what makes x to the 4th? X squared and x squared. And then what multiplies to make 6 and adds to make negative 5? What if I did a minus 6 and a plus 1? Oh, no, because that would make negative 5, but if I multiplied them, it would make negative 6. That's not right. Is there anything that multiplies to make a positive 6 and adds to make a negative 5? How about if they were both negative and it was a 2 and a 3? Would that work? I think so. I think we got it. Now, this isn't a difference of squares or anything, because 2 is not a perfect square, and neither is 3. So I don't really have a good way of factoring those yet. That was a teaser. So for today, this is a fine way to write that. Okay, I can't leave you hanging. Technically, we could pretend that was a difference of squares if you wanted to get into weirdo numbers, like irrational numbers. What times what makes 2 and adds to make 0? Square root of 2 and square root of 2. Same thing for this guy. So if you want to be all advanced and smart, you can do that now, but we'll talk more about that later.